6a. Consider the differential equation. Okay, at that moment you should be thinking, they're giving me a rate. And therefore there is an amount. When you see dy dx, your brain should say, okay, y is the output variable, x is the input variable. That's always how a derivative is structured for our class. So we have an amount formula. That's going to be y equals something with an x in it somehow. I'm just making this up, I don't know. So y is equal to something with an x in it. And we have a rate formula. Our rate formula is this formula here, dy dx. So that's what we are starting the problem with. It's what we have when we begin. A slope field for the given differential equation. So a slope field created using this is shown below. Sketch the solution curve. That means sketch the curve for the amount. The solution to a differential equation is the amount equation. So we want to sketch the amount equation if the amount equation passes through this point. There's a comma, so you should stop. So I come down here. When the amount equation passes through the point 0, 2, you can see from this picture that the slope of that amount equation is going to be 0 or flat. Please pay close attention to when I say the word rate versus when I say the word amount. The rate equation, the differential equation, creates the slope field. But because the rate is computing the slopes of the amount, the field is a picture of what the slopes of the amount would look like. So if the amount curve went through the point 0, 2, the amount curve would have a slope of 0. And then you just follow the field. Well, there's nowhere else to go but like so. So the amount curve apparently would be completely horizontal if the amount curve were to pass through the point 2, 0. Now we sketch the solution curve that passes through the point 1, 0. So now if the solution curve is passing through the point 1, 0, that's here. That means the amount would look like that as it passed through the point 1, 0. And now you have to follow the field again. So as the curve passes through the next point, as best I can follow, looks like I'm starting to kind of curve a little bit. Something like that. I follow this way, doing my best to do whatever the curve does here. Something like this. And if I do that, as you see here, 1 point for the solution curve that passed through 0, 2, and then 1 point for the solution curve that passed through 1, 0, 2 total points on part 6a.